Welcome to Lesson 3, Interpret Cost and Revenue Models Using Graphs. Our objectives are to identify graphs of revenue, cost, and profit, identify and interpret key components from graphs of revenue, cost, and profit, and then finally to be able to sketch graphs of revenue, cost, and profit given certain scenarios. The graph down here represents a revenue line, a cost line, and a profit line. All three. We are now going to put those together and we're going to illustrate those graphically. Let's look at this graph. Identify which line represents revenue, costs, and profit. And then after we do that, what do you notice about the slopes of the lines and the break-even points? Well, first, let's think about our revenue. We learned last time that when we sell 0 units, we have 0 revenue. The only line that's 0 is this blue line. So this will be our revenue line. You can easily identify the revenue line when it's a linear equation because it goes through 0, 0. All right, let's identify our costs. Remember that our costs, we have a combination of fixed and variable costs. When we don't produce anything, we still have to pay our fixed costs. So which one shows an actual amount if we don't produce anything? So in other words, our units produced are 0. Well, this red line shows 20, and this green line shows negative 20. Well, we know that if we don't produce anything, we have these fixed costs still of 20. So this equation here represents our costs equation. And remember that our slope then represents the variable costs. Finally, we have our net profit equation, which represents our revenue less our costs. It has to be this final one down here. So when we're thinking of net profit, when we don't sell anything, we don't bring in anything, however, we still have $20 of cost in this example. So we would have a loss of $20 if we didn't sell any units. Okay, now let's think about the slopes of our lines. Well, notice that we have a point here. Remember that point, break-even point. We are able to have this point here because our revenue slope is steeper than our cost slope, which means that we are bringing in more money per unit than what it costs per unit. What would happen if our revenue slope was not as steep as our cost slope? Then these lines would never intersect and we would never have a profit. All right, now let's look at our break-even point. Notice that this break-even point where our two lines intersect coincides where our net profit crosses the x-axis right here. Think about what our net profit represents. Our profit always represents our revenues minus our costs. If you remember from an earlier lesson, this area in here represents a net loss. What happens when you get to this break-even point? Well, above that, we end up with a net profit. So notice that if we follow this net profit line, we do not make a profit down here. And in fact, we lose money all the way until we get to, this is approximately 6.6 units sold, something like that. So after this point, we start making a profit per unit. So we have to sell a minimum of 6.5 or 6.6 units before we actually start making a profit. It's no coincidence that the break-even point will always correspond to where the net profit crosses our x-axis. Remember, our x-axis represents the number of units sold or produced. Let's do a little more analysis. Let's go ahead and look at the slope of our revenue line and then of our cost line. So let's find a point that has a crosshair. It looks like right here. At 5 units, we have $40 of income. So if we find the slope of that, 40 divided by 5, and I can do that because we start at 0, 0, We know the slope of this line is $8 per unit. Let's compare that to the slope of the cost line. Let's find a couple of crosshair points. It looks like we can look here and we can look here. So let's look at this rise over run. This rise, we go from 30 to 35, so that's a rise of 5 over a run of 1. So that means that our price per unit, or I should say our cost per unit, is $5. Compare these two. If we take the difference, that means that our net profit per unit is $3 per unit. And we could find 2 points and compare the rise over run to prove that. So think about your slopes. If your revenue was steeper, meaning we charged more, that difference would become more and our net profit would go up. On the other hand, if our revenue was less, we charge less, maybe only $6, then that difference is only 1 and our net profit line would become more shallow. So always think of the correlation or how these three are interrelated: cost, revenue, and profit as far as their slopes go. Let's look at example 2. Here we have a cost equation. And what we want to do is graph this equation and then determine what we should charge in order to break even after 10 units. Okay, how are we going to do this without a revenue equation so that we can see the intersection? Let's examine this. Let's graph our starting point, or our fixed expenses, at 35. And that looks like it would be right about here. Now let's graph our slope. Well, our slope is 4 over x. So that's a rise of 4 over a run of 1. Well, a run of 1 is not a problem, but it's hard to find 4. So let's change this a little bit. 4 over 1 is the same thing if I multiply both the numerator and denominator by 10 as 40 over 10. That's probably a little bit easier. Since these go by tens, I can do 10, 20, 30, 40, and come all the way over here to 10. All I really need are 2 points in order to draw a line. Now I have my line, but how am I going to find out what I should charge in order to break even at 10 units? Well, let's look at where 10 units is. Right here. So that puts it right here. Well, if I draw a line from 0, because we know that our revenue always starts at 0, I would get a graph that looks something like this. All we have to do then is figure out the slope of this pink line, and we know how much we need to charge in order to break even after 10 units. Well, remember, since we start at 0, I can just look at my rise over run from 0 to this point. And we know that this point is probably about 60, 75 over 10. If we divide those out, we know that we need to charge $7.50 per unit in order to break even if our variable costs are 4 and our fixed costs are 35. This is in order to break even after 10 units. Let's look at a third example. In this example, it says, after how many units do you start making a profit? What could you change to make a profit sooner? Well, this is going to be an easy one because we just talked about this. Let's go ahead and graph our equation. So we have a y-intercept of negative 18 and a slope of 2 over x. And again, I think it might be easier to multiply, or slope of 2 over 1, I should say, to multiply both the numerator and denominator by 10 to get 20 over 10. I went ahead and plotted my y-intercept of negative 18, which is what my profit would be if I sold 0 units. And then I went up 20 and over 10. Now all I'm going to do is connect these dots together, and I'll see my profit line. So if we look at this, we can answer the question. After how many units do you start making a profit? Well, notice right here is where the line crosses the x-axis. That's at 8 units. So the answer would be 8 units. Now what could we change to make a profit sooner? In other words, if we were to redraw this line, how could we cross the x-axis sooner? Well, there's two things we could do. We could either decrease our fixed costs so that our line, still with the same slope, meaning that our cost per unit and our price per unit stays the same. Notice the change. We went from selling 8 units to break even to selling about 2.5 units to break even. That's one thing we can do. Maybe stop the tape and think if there's something else that you could do. All right, well, hopefully right now you're thinking, what if we changed our revenue or we changed our variable costs? And you're exactly right. If we increase what we're selling our products for, or if we decrease the cost per unit, we can create a steeper net profit curve so that it could look something like this, or even steeper. And if we did that, notice that once again, we are crossing the x-axis sooner than the 8 units here. Those are two ways to help us make a profit sooner. Let's look at example 4. In this example, we're going to sketch a graph with high cost per unit and low startup costs. Let's think about what that might look like. High cost per unit, we know that represents the slope. Anything that says per unit is paired with the x. So this is going to be the slope of our line. Low startup costs, this represents our initial fees, right? Our initial costs, our fixed costs. So this represents our y-intercept, or b. What would that graph look like? Think about that for a second and then turn the video back on and see if you're correct. Okay, so if we look at something that has low startup costs, that means that our initial b value is down here, somewhere low. But since our slope is fairly steep, because we have high cost per unit, our line would look more like that as compared to this or this. So this is a good sketch of something that has low startup costs and high cost per unit. Let's try another one. In this example, the company is hardly making any money, even though the gadgets are selling well. The company had large startup costs, but not very high production costs. Okay, let's take this one a little bit further. So we're going to first sketch our cost equation, and we have some key information that we need to follow. The company had large startup costs. What does that mean? Well, that means that we have pretty high fixed expenses. So we're going to be up here somewhere, let's say. But they didn't have very high production costs, so we know that our slope isn't going to be quite so steep. So let's draw on a sample. Maybe like this. Very shallow, not such a steep line. Well, let's continue on because it says the company is hardly making any money. This means we need to find out something about our revenue equation. Well, in our revenue equation, if we're not making much money, that means our cost per unit, our selling price probably isn't that great. It's not that steep, right? It's fairly low. So we know that our revenue equation starts here at 0. Let's go ahead and draw in a sample revenue equation. We'd start at 0, and instead of being something like this, it would take us a long time to maybe cross. In fact, we could even have it be shallower and just increase the length of our cost equation here. So that way we can see that it takes a long time before we even make money. And then once we make money, these lines won't separate very quickly. As compared to, if I took my revenue line here, my revenue equation, and I charged a lot more, notice how quickly this revenue goes up compared to our costs. So even though we have high startup costs, high initial costs, because our cost per unit is shallow, we can end up making a lot of money quick. However, in this example, they say that they aren't making very much money, so they're not charging very much, which means these two lines aren't going to separate from each other very quickly. Let's look at one final example. How can we improve profits without increasing revenue. So go ahead and pause the tape or the video and think about this on your own. We've talked about this a little bit, and see what you come up with. Well, hopefully what you came up with is the only way to change profits without changing revenue is to change our cost equation. So our yellow equation is our cost equation. We can do a couple things with that. We can either take it and move it down and what I've done is I've moved it down here. So from the yellow, I moved it down here. We'll call this one in white, we'll call this our first choice. Not necessarily our first choice, but one of our choices. So we could take our entire yellow cost equation and shift it down, keeping the same slope. Notice what happens to the break-even point. It moves to the left, meaning that we break even sooner and we start making profit sooner. So this is one way we can do that, and that would be to change where our fixed costs are. So decrease our fixed costs. Maybe instead of having a space that we rent, we just do it out of our house, for example. The second way would be this pink line, and that would be to decrease the steepness of our cost per unit. So that means decrease what it costs us per unit to produce the product. With the economy and all the changes and the job layoffs, a lot of companies had to learn how to become more efficient and so learned how to decrease the cost per unit. Notice what happens to our break even here. It has also shifted to the left. So either one of these ways will help us to improve our profits without increasing our revenue. Think about the advantage of this. Consumers don't want to have to pay more for the same product. So if you can become more efficient within your business, you can get more revenue quicker or more revenue per cost of your unit that you produce. And that concludes our lesson today on modeling using revenue, expense, and profit graphs. So at the end of this lesson, you know you will have been successful if you can look at a graphical representation and identify which of the lines is your revenue, your cost, and your profit graphs. You should also be able to identify and interpret some of the key components from the graphs, including your break-even point, as well as understanding how the slopes interplay and relate to each other. And finally, you need to be able to sketch graphs of revenue, cost, and profit given different scenarios.